Hi, everyone. In this video, we're going to go over chapter 23, which is bivariate statistical analysis, measures of association. So we are going to go over those first 2 points, which is apply and interpret simple bivariate correlation, and then interpret the correlation matrix. So the other points actually, which is the simple regression and then multiple regression, I explained that in the other video. So measures of association. So it actually refers to the number of bivariate statistical techniques used to measure the strength of relationship between two variables. So anything that starts with bi, bi, that refers to two. So bivariate, so represents two or refers to two variables, right? And then the chi-square test is used to provide information about whether two or more variables that are not measures, they are not continuous, right? If they are ordinal or they are actually nominal, right? Because ordinal variables, sometimes we use them as, well, we assume that they are continuous variables, right? But we will talk about that in a little bit. And then correlation analysis is, again, it is very appropriate when we have interval or ratio variables, meaning when the variables, both variables or two variables are continuous variables, right? Like age, weight, right? Sales, and so on. And then regression can also accommodate if we have, let's say, a nominal variable or categorical variable, like gender, and we want to see and performance. Performance is the continuous variable, and gender is the binary or the categorical variable. Actually, we can use regression to see the relationship between those two. We can also use some other like the t-test that we talked about the other week, last week, right? And so on. So regression can accommodate either less than interval or interval dependent variables. But for regression, the dependent variable or the outcome variable must be continuous, right? So, and I believe we covered that in the data mining tutorials when we use regression or linear regression. So here, when we talk about regression, we're referring to linear regression, right? So we can use linear regression when the dependent variable or the outcome or the target variable is continuous. If the target variable is binary or categorical, in that case, we use logistic regression, which is beyond the scope of this course. And actually, we show that in the data mining tutorials. You can use that actually. So this is kind of the roadmap for associations for two variables. So the first question for the decision is we want to know what is the measurement level? What is the variable type, right? Is it nominal? So that means categorical. In that case, we are going to use a chi-square test, right? Like what we did in the previous chapter in one of the examples when we use the chi-square. And then ordinal, again, ordinal here, we say we, in at least in our project and also in most research, ordinal can be assumed to be a continuous variable and we can use it as such. But if you want, for example, you have a question like this, research question is between only two variables. Does importance ranking relate to brand choice? So the brand choice here is the nominal variable or the categorical, and then the ranking is the ordinal, right? In that case, you can also use chi-square, or you can use correlation as well, right? And I will show you how to use Spearman and correlation in a little bit. So the interval ratio that represents the continuous variables, right? And then when we have two continuous variables, then we can use Pearson or the correlation or simple regression to see whether they are related or those two variables are related or associated with each other. So correlation coefficient, that actually represents for us the strength of the relationship between two variables or two continuous variables. Covariance also kind of represents the strength of the association between two variables. So I will not let you worry about the equations here because we are going to use Excel to calculate those things for us. So again, the correlation coefficient, which is the R, it ranges from -1 to +1. So the -1, that means the relationship between two variables is inverse. So when one variable goes up, the other one goes down. So that's the negative. And then the positive is the strongest relationship between two variables or two continuous variables. So that means it is when one variable goes up, the other one also goes up, right? So that's what we mean here by positive or linear relationship. That's the perfect one, which is a +1, and the perfect negative or inverse linear relationship is -1. If there is no relationship, then the closer to the zero, the less the correlation or the relationship between two variables, two continuous variables is, right? And we will see examples in a little bit. Again, we will not worry for now about the equations here because Excel also calculates those for us. And those are examples of the correlation coefficient and the strength of it. So for example, when it is 3 in this case, so let's say that I 0.3, which is closer to the positive. So this might be like this, like straight, should be straight, right? But this is 3. 80, it is almost perfect. Almost perfect. Erase that or clean this guy. So this one is almost like, oops, I don't know what it does that, but almost there. And then the perfect, so this is straight line. I don't know why it is doing that, but this is straight line. So what I mean is this one, right? And then for the R, when the R is 0, that means it is flat. There is no, actually, it doesn't go, it is not positive and it is not negative. It's almost flat, right? And then for the negative, 60, it's like this. And then the perfect one correlation is straight line, like this. So when one variable goes up, the other one goes down, right? So that's the negative relationship. And perfect correlation. Again, so when we have two variables that covary and they display related variation, right? And this systematic covariation does not necessarily mean causation. So again, what we say correlation does not mean causation. That's very important. So what we mean by that is that, for example, my age is correlated with the price of gas. So it doesn't mean my age caused the price of gas to go up because it doesn't make sense, right? So this is what we mean here. It is a correlation, but it's not a causation. But if I say my age caused the number of white hair to increase in my hair, yes, then that correlation actually makes sense. It is a causation, right? My age causes my hair to become white, right? Or the number of hair to become white, right? So correlation doesn't always mean causation, and we need to be careful about that. So coefficient of determination, which is the R squared. So basically it is the correlation, and we squared the correlation score, and then we get the R squared. So what is the R squared? As I explained it in the regression lecture, but the R squared is, imagine that we have two variables. So we have here performance, and we have here, let's say, perceived inclusion. So when a person, an employee, perceive themselves to be included in the workplace, they are heard, being heard, they are recognized, and so on. Then let's say now inclusion, which is variable 1, and this is variable 2, and R squared represents actually this space that inclusion or variable 1 explains or correlate with in variable 2. So in other words, let's say this is 20%, 0.2. So we can say 20% of performance is explained by inclusion. And the rest of the 80% is explained by other variables. It can be innovation, it can be good health, exercise, it can be great leadership within the organization and so on, right? But you saw that. So this is what we mean here by R squared is basically the proportion of variable 2 that is accounted by variable 1. And I also explained that in the regression lecture for you as well, right? So then we can create correlation matrix. Excel can create for us, especially if we have multiple, more than 2 variables, continuous variables, or more than 2 variables. Actually, correlation matrix can be created in Excel, and I will show you how to create one in a little bit. And then we can also calculate the statistical significance of the correlation, and I will show you an example as well. So I will stop here for this. And actually, this is how the correlation matrix looks like. And I gave you also in the example paper that I showed you, I have a correlation matrix for only 3 variables. But the more, if we have more variables, it's going to look like this. So again, the performance, which is here S, because when we correlate performance with itself, then it's going to be perfect correlation, which is 1. Right? And then the correlation between job satisfaction and performance is almost 50%, right? Or 50 or 0.45 and so on. And then they used here the letters kind of to represent the p-value significance level. For me, in my paper, or the majority of scientific papers, they use the asterisk or the star sign to represent, 1 star represents 0.05, less than 0.05, and 2 star represents, or 2 asterisks represent less than 0.01, and then 3 asterisks represent the p-value when it is less than 0.001, right? You can do that as well. So we're going to, again, stop here. And this actually tells us what is the relationship between, kind of the correlation between variables, or the relationship or the association between 2 variables. So for example, verbal intelligence is negatively correlated with performance, right? In this example. How they measure it, that's, we need to know how they measured all of those in order to be able to elaborate, right? But you got the idea here, what we mean here by correlation matrix. So I will stop here because in the next video, in the regression video, I explain actually simple regression, and then I go into multiple regression, and I explain also the regression equation and so on. So now let's move on to the example that I wanted to cover with you. So I provided to you in Blackboard. So if you go to week 6, and then I have provided to you this Excel file, which is correlation example update. And I'm going to put this video that I'm currently recording for you here. Right. So this is the Excel file. When you open it, download this file, you will have actually this file. So here it shows you how correlation used to be calculated when we use the scientific calculators, or when we used to do it manually. So it was very cumbersome, and takes forever. Right. I remember in one of my finance classes, we had to do this manually for an exam, and that was just one question, and it took almost 45, almost 45 minutes out of that 1 hour just to calculate this manually. And simplest mistake, then it ruins the whole thing, right? But don't worry about this manual. So we'll just go to this. We have two variables here. So we have unemployment rate, and then we have a number of hours worked. So now we want to determine if there is a relationship or a correlation between unemployment rate and the number of hours worked. So to do that, what we can do is to calculate correlation and Pearson. So either one will work. So to calculate correlation is you can use a function in Excel, which is equal, and then correlate. So when you correl, click on it, and then it asks you for array 1. And then I will put comma, array 2, and then enter. So now this is the correlation. So the same thing, Pearson also will give us the same output. And then, so this is the correlation between unemployment rate and the number of hours worked. It is a negative correlation, right? But is it significant or not? That's the question that we want, right? So the number of observations, as you can see here, you can actually, to know, instead of using the count function, you can just highlight those. And then you will notice that it automatically tells you the count, the sum. We don't need the sum or the average. We're interested in the count. So we can see that it is 19. Or you can use even the function to count. And then it will give us a 19, right? So now for the t, we need to use this function, right? So for the t, it is the r times, and then the square root. So the square root function, and then n, which is 19 minus 2, that will be 17, right? So n, which is 19 minus 2 will give me 17 divided by, that is 1 minus r squared, which is, what is the r, this guy? Either one will be fine. Raised to the power of 2. And then enter. Let's say square root. Yeah, I need it. So the square root of this. And then, so let's see. Yes, this makes better sense. So I got 77 for the t. So now let's see. All right, so now let's look at, actually now it should be, let me show how I calculated it here, 1 minus. So this is basically the correct one. The one I calculated here is not right. So the one I calculated here is the R, which is actually this one, right? For me, I did the opposite. So R times the square root of 9, which is this cell, minus 2, divided by 1 minus R squared. And then, which is basically, you can do this, multiply it by itself twice, or you can just do raised to the power 2. That will also give us the same number. So now we got the t-test here. So now for the degree of freedom, which is n, which is 19 minus 2, that will give us 17. Now to calculate the p-value or the significance, so we need to use this function, so which is distribution, the distribution, let's see, TD, so TDS, and then we use the absolute function. So we used absolute function, TDS, and then ABS. And then we can use the T, which is this number, the value, degree of freedom, which is this guy, and then two. Then I need to close this guy. So T value, absolute. Absolute T value, close that guy. And then I have degree of freedom. Then I have the tail, and now I get this number. So this is significance level, which is less than 0.00, actually 0.01, right? So again, for us, we want our p-value to be less than 0.05. As long as it is less than 0.05, then we can argue, or we can say that, and our conclusion will be there is a significant correlation or association between unemployment rate and number of hours worked. So this should be our conclusion. And so I have done this one as an example for you. Now I will let you work on this one by yourself, and you can submit this for this assignment, for this training, right, in this assignment. So now for this next one that I'm going to do, you don't have to submit it, but this one can be related to your project. So this is the data set that we cleaned for the class, right? And for me, I created some variables. For example, for gender, I added one column here, and then I used an if function, and I called this variable, it's a binary variable or a dummy variable, and I called it female. The existence of female will be 1. The non-existence of female will be 0. So you can use an if function here, right? So to do that, you can just say if this equals female, then 1, otherwise it is 0. So you can do that for that. For education, what I did is you can do the same thing. I believe I have explained this before in another tutorial, but you can do then remove duplicates, and then you can so high school will be 1, 2 years 2, and then 4 will be 3, then masters will be 4, PhD will be 5, right? So you can use this one as a VLOOKUP. For example, here you can add a new column, and then you can call it education, right? And then you can say equal VLOOKUP. And I explained this actually in another video. So this guy, the value, and then the array, I can just go to the array here. And then I will make sure to click on F4 to make it absolute. Go back. Then comma index, it's 2, actually the second column that I want to return here. And then I'll select false exact match. Oops. Let's just remove that. So let's see. Lookup value is this one. So it didn't capture this guy. Then I'll say 2. So now you would notice that. So again, 2, I need to say here false. So it can be exact match. Exact match will get rid of those NA. So you get the idea now. You can do the same thing for yourself for unemployment rate, unemployment. Also, you can do the same thing. And also I did for Hispanic because the race, we have different races, but the majority are Hispanic. So we want to control for the Hispanic race. You can do the same thing. You can use even if statement like I did for the female here. Okay. So now I have my variables are ready. And again, there is another thing for GPA. Some of the students didn't, or some people didn't report their GPA. So what I would suggest is select or highlight this column and then see what is the average. So the average here is 3.44, right? So now there are a couple of observations that they didn't report. Now you can actually do imputation or replace with the average of that column. In this case, it is 3.44, right? I can just use this one for those didn't report, 3.44. So now I have everything because one thing about Excel, it requires that all cells, they have to have values, otherwise it will not you work using the data analysis feature or function in it. So now let's look at the numbers that we have here. So we talked about the correlation matrix, right? We talked about the correlation matrix. So let's create a correlation matrix for those variables that I have here, right? So I have all the variables that the constructs that we averaged, and then we have those guys are the control variables. And I expect you, if you are using, for example, if your hypothesis is looking at the relationship between two variables, I want you also to control or to include those variables into your regression model, right? And to report those control variables as control variables, right? So let's see. Now let's create correlation for those variables, and you can use that. Feel free to use that for your results portion of the assignment. So here, correlation, and I am going to Control A just to select everything. And then I have selected labels in the first row where I want my output. Yeah, I want my output to be here. That way you can see it. All right, so now you can see that my correlation table is beautiful, right? So now you can see that the correlation between performance and itself is perfect, positive, right? Positive correlation. Now you will notice that there is correlation between performance and inclusion. The other ones, the closer to the more zero, that means it doesn't have correlation or that it's not related. But you get the idea now. But this doesn't report for us the significance. So instead, we are going to use multiple regression. So let's assume that I wanted to test if there is an association or relationship between performance and feeling included, right? So those are the only two variables that in my main hypotheses. But again, since those are only the main hypotheses, the main two variables, I need to control for those other variables like exercise. Usually it's the demographics, but if you add exercise, sleep, so age, what gender, which is represented by female or non-female, employment status, student experience, GPA, education level, and Hispanic, right? Whether the OCs are representing race. So what I will do is I will copy those two, and then I will copy also, and I will highlight all of them, Control C, and then I will add the new. So those are the ones that I'm interested in. Performance is my Y variable or my dependent variable, and I want to regress all of those guys with performance. So to do that, I need to go to data analysis, and then I will use regression. So Control Shift, and then the down arrow to select, and then I will select just here, and then Control Shift, and then downward arrow. It will select everything for me. So I have labels. I will keep them there. The output range, I'm going to select the output range. I will just put it here. That way we can see it. So now this is my output. Again, as I showed in the other tutorial, we need to report in the results. We need to report the R squared, similar to what I have in my example that I provided to you. And then, so this guy is significant. So this one, I'm going to change it to numbers, and then I'm going to increase, so put it maybe 4. All right, so now I can tell which variables are significant. So this guy is significant, and this one. The other ones, they are not significant. So why we should include the control variables? So we can safely say that inclusion is positively related to performance regardless of gender, age, employment status, student status, GPA, experience, and education, and race, right? So this holds regardless of, so in other words, we are already in that Venn diagram. So we are already, anything that counts for performance, we are already accounting for it, right? So those are the beta or the beta that you saw in my example I report. I would report this guy and the p-value. So the other one is this guy. So those are the only ones that were significant, right? And feel free to use this whole thing to put it in your paper as well. But you will need to explain it similar to the way I explained it, right? So this is that's all that I wanted to go over. So if you have, you know, you want to test the hypothesis only between two variables, I would suggest that you need to do multiple regression. So the regression in this case, we are studying inclusion with performance, right? And this is basically the coefficient. And I will stop here, and I hope this helps, and wish you all the best.